Today's episode is sponsored by Wohlers Associates, powered by ASTM International, an objective source for technical and strategic consulting on new developments and trends in additive manufacturing. Visit them at WohlersAssociates.com.
Aerospace and defense manufacturing.
Machines and automation.
Additive manufacturing.
Smart manufacturing.
The global manufacturing economy.
Welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals, powered by SME. From the design screen to the shop floor to final assembly, we drive the conversation about making manufacturing smarter by connecting people who are passionate about manufacturing.
Hello, and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. I'm your host, Steve Plumb, Editor-in-Chief for SME Media. I'm joined today by Terry Wohlers, and for anyone in the additive manufacturing industry, Terry doesn't need much of an introduction. He's been chronicling 3D printing almost since the technology's inception. He currently is the head of advisory services and market intelligence at Wohlers Associates, which was acquired by ASTM International a few years ago. And perhaps most famously, he's the man behind the annual Wohlers report. Terry, welcome to the show. It's great to talk to you again.
Thanks, Steve. Good to be here.
So I gave a brief synopsis of your history and background, and I know I mentioned the Wohlers report. The 2024 edition just was released. How many years has it been now?
The 2024 edition marks the 29th annual version of the report, so we've been doing it for a long time, almost 3 decades.
So I'm sure you've seen a lot of change over the years. Anything that really stands out? What was it like back in the 1990s?
Well, in some ways things have changed a lot, but in other ways they really haven't. I mean, we're still talking about a process that builds parts layer by layer from computer model data. It gets sliced up and printed one layer at a time, and so from that standpoint, the process, of course, there's a wide range of them, but it's very similar, and the applications are more or less similar to, if you compare to the 1990s to today, for design validation, concept modeling, prototyping, tooling, and then manufacturing applications. And the latter is where we've seen the most change, where companies now are really putting this technology to work for fairly serious manufacturing applications, particularly in aerospace, healthcare, some consumer products. We're seeing the energy sector begin to adopt it. And so that's been the biggest change. And of course, machines are bigger, faster, better, more reliable. The range of materials are really pretty impressive compared to the past. So we've seen those kinds of changes, and that's all encouraging. And of course, growth has been strong too.
So of course, we encourage everyone to get a copy of the report and read through it. I'm working my way through it still. Notice some interesting data and information, but any kind of top line highlights that you can give us, that you can share with us?
Sure, I'd be happy to. Last year wasn't as strong as some of the years in the past. If you look at the past 35 years, that's the length of time in which we've been tracking this industry. It's grown by 25.2% every year on average. And so last year it grew by 11.1%. If you look at the last 4 years, it's grown by 14.1%. And of course, that includes the pandemic years, which 2020 and a large part of 2021 was mostly shut down, or at least largely. So in terms of new product development and manufacturing, so those are some of the high level numbers and figures that we've collected. Material sales are still quite strong, and we're seeing some bumps in the road. First quarter of this year has not met expectations, but first quarters of most years are soft, and so we're not entirely surprised by that.
I see you still have a pretty robust growth projected for the industry. I think getting close to $100 billion within the next decade or so. What's really driving that, or what has driven it in recent years, and what do you see to continue that trend?
Well, we're seeing manufacturing as being really the growth driver. We've had more than 3 decades to figure out how to apply the technology to modeling and prototyping applications in a wide range of tooling applications, from jigs and fixtures to molds for plastic injection molding, and a wide range of other types of tooling as well. For example, sand casting and so forth. So, the next frontier has been for the last decade or longer, really, manufacturing quantities. And I'm not talking about hundreds or millions of parts. It could be, where each design is unique in the sense of Invisalign from Align Technology, where for straightening teeth, and jewelry designs, and relatively small volumes of parts for aerospace applications. Some orthopedic implants are fairly high volume, from the likes of DePuy Biomet and Stryker and others, and some are custom, but still the vast majority are series production, or the similar to what they've been done in the past, but using additive manufacturing to produce them.
And you mentioned series production and making that transition from rapid prototyping and niche applications. So how big, how large in terms of volume are we talking about? And is there a threshold of when it makes sense to do additive versus traditional manufacturing?
Yeah, that's an interesting question, and one that needs to be asked whenever you're looking or considering the use of additive for actual part production. So it really comes down to, of course, a number of factors. One is part size, and another is quantity. Of course, that's assuming that the material and surface finish and mechanical properties all align with the requirements of the part or product that you're producing. But there's a break-even point, meaning that at some point, additive manufacturing is less expensive or more expensive at a certain quantity than using conventional manufacturing. And companies need to go through that analysis in order to determine whether or not it makes economic sense to use additive. Now, what becomes involved is this. If you're simply using the same exact design as for conventional manufacturing and applying that design to additive, it almost never makes sense. Maybe for spare parts, that sort of thing, it can, one-off types of parts, but in series manufacturing, it does not. So then how do you achieve that? How do you use additive so that it does make economic sense? Well, it's almost always through design or redesign. So, for example, looking at a part or multiple parts in an assembly and consolidating those parts digitally and then printing those out. Also, you can improve performance. Not always, but often you can improve performance by using additive manufacturing. And so that's also a benefit. You can often... Well, I shouldn't say often. It depends. It's on a case-by-case basis. So you really have to look at this and say, okay, can we remove material, optimize the design by using the least amount of material to get the job done? And losing material, of course, that's a reduction in cost, but it's also a reduction in weight, which can be important if it's an aerospace application or a vehicle of any type. So those are the elements that need to be considered when looking at the use of additive for, production applications.
So have companies gotten better at designing specifically for additive?
Yeah, I would say overall they have. It's taking maybe a little bit more time than we anticipated, because it's not only just buying a product, which can be expensive, and I'm typically referring to a software tool or set of tools and used to, do this design work. Now, you can start with your standard CAD solid modeling tools, but other types of tools are available to help you optimize the design. So that's really not only the software, but the know-how, the learning, the software, and applying it to your application. That's where companies can get hung up because they see additive as a candidate for manufacturing, and then they begin to look at what's required to build a business case around that, and that redesign can take investments in software, investments in training and practice over a period of months to then learn whether or not it makes sense to use additive. And so that's difficult for companies.
You mentioned the importance of materials, and materials are being developed specifically for additive now too, and also the waste equation, eliminating waste, which not only has cost and time benefits, but also environmental benefits. But can you talk a little bit more about the new types of materials that are coming out, and in some industries where the materials are sourced can be an issue, especially if they're overseas. How does additive play into that larger equation?
Yeah, so for many companies and government agencies, materials are so vitally important. And in the world of metals, we're seeing a growing number of materials. Most of the powders we're seeing today are around aluminum, some titanium alloys, nickel-based superalloys, different types of stainless steels, and other materials too. And so those materials are being applied to actual manufacturing. Not all, but many are. In fact, metal AM really almost from the beginning was used for actual production, which is quite different than with polymers that really didn't get started that way at all. And so we're seeing a growing number of alloys in the world of metals and also polymers, across many different types of AM processes. And I'm talking about of course polymer processes, powder bed fusion and material extrusion and so forth. And so as we see these new material products become available, that only expands the range of applications and what companies and other organizations can do with them. So it's an encouraging development, and we just keep seeing more and more. Still a relatively small number of materials available compared to conventional manufacturing. So we have work yet to do.
So with the new materials being developed, and especially as companies are designing specifically for additive, is that another way to enhance performance, especially with complex shapes where you can pinpoint where different types of materials are used in the part?
Yeah, well, that's something that was developed many years ago, and we really expected to see a lot of that sort of thing where we could put different types of materials in various places and have graded surfaces or graded areas within the part. And technically it can be done, but it really hasn't taken off because there are some real implications on the data side to define, where that material should be and then to really understand the performance benefits of that as well. And so we really haven't, we have seen work in that area, but not as much as we expected. But with that said, we're still seeing a lot of new developments in composites, carbon filled and other types of glass filled and so forth, and so that's important. Of course, we've had those materials around for 15 years or longer, some of those materials, but we are seeing processes that can better accommodate those materials. So that's an important development as well.
So on the material side, do you see more potential or flexibility on the composite side versus the metal side? Or?
No, I wouldn't say more. I would, it's, just there's room for development around the composites. And so, I mean, it's going to be based on demand as organizations demand certain types of composites. And not only that, but ceramics too is also something that's taking off. Not in a big way because there aren't as many applications for ceramics as other types of polymers, or polymers in general, rather. But still, it's an area of development that we should be watching.
So, additive manufacturing has been around for more than 30 years now. In some senses, it's still in its infancy and early stages. And it seems like new applications and technological advances are being announced almost on a daily basis. The Wohlers report is a good way to catch up on a lot of what happened in the last year. What were some of the things that's caught your eye? And I know you mentioned a few of them in the report.
Yeah, well, one is that we're not seeing a decline. In fact, it's quite the reverse of that in the number of system manufacturers that are being formed and commercializing products. I think we counted 328 companies worldwide that offer machines that produce, these would be classified as industrial machines priced at more than $5,000 each. And that's not all of them. I mean, that's the ones that we could find worldwide, but that's many. So, organizations, customers of these products are choice is good. It's good to have a wide range of options when choosing products, but I suppose you could argue that there's maybe too many to figure out which one's the best for them. And then, like I said, materials, we're seeing, a wide range of them as well, but that's not as difficult because you can, hone in on the material that you need and get them at competitive prices, more so than today than you could before. So I'd say that's one development. It would be the number of system manufacturers that are, popping up around the world.
And I think I saw you mentioned that back when the first report, there were only 8 such system providers. So it's grown to over 300 now?
328 is what we count. And that does not include the lower cost desktop 3D printers that are out there, some of which produce really very good quality parts, amazing in fact, and to the point where many are being used for actual manufacturing. My son-in-law, for example, he's started a little company to manufacture an aftermarket product for a Jeep Grand Cherokee since like 2011 through 2020 something, and I've got it right here, and it turned out beautifully, and it was manufactured on a low-cost system, and it looks beautiful, and he's already sold about 75 units and just got started. And so we're seeing that kind of development that without 3D printing, we wouldn't see these little startup types of companies, and so that's exciting.
So, what role do the startups play in the whole ecosystem? And as with any other business, some of these startups will eventually either get seed money from a larger company or be acquired by a larger company.
Yeah, so we've seen hundreds, and there's probably thousands of companies out there that have started up a little business around 3D printing, whether it's a new software tool or a web-based platform of some sort, or a product like our son-in-law's doing, just everything in between. And it's really amazing. It's really interesting watching these companies develop, some getting funded, some growing, and then being acquired. Of course, history shows that about 9 out of 10 don't make it, unfortunately. So, but that's not only in additive manufacturing and 3D printing. That's across the board, all startups. But this is a very interesting and vibrant industry, and I'd like to think that more than 10% will make it. I mean, it's we personally haven't done any studies to determine whether or not that's the case, but we have followed some venture capital companies like AM Ventures, based in near Munich, and watching it fund companies, the likes of Elementum 3D, which is a Colorado-based company that does metal powders, and so it's interesting to watch these companies grow from a little bitty startup to something much, much bigger.
And at the same time, some long-standing traditional manufacturers such as Nikon are entering the field. Are we seeing more and more of that happening?
We are. Japan was one of the early adopters of the technology way back in the 1980s, and then Japan as a country really went almost quiet in this area for a very long time. But in recent years, it has really made a commitment to the technology, and it's interesting that Nikon is doing what it is doing with SLM solutions, and before that more 3D, and so I think it's an example of what we will see in the future of large established companies that may have been in additive, but in a very small way make a decision to be all in, or at least in additive in a much bigger way than it had in the past.
We mentioned Japan and how it's gone back and forth a little bit, but China also is getting into additive in a big way. Where does the U.S. stand right now in terms of competitiveness and development and implementation?
Well, the three big regions of the world, and perhaps this goes without saying, it would be the U.S., Europe, and Asia, not necessarily in that order. And then if you look at individual countries, U.S., Germany, and China, and again, not necessarily in that order. It depends on what criteria you use to, is it the adoption and the use of the technology to produce product? If there was a way to quantify that, I would guess that the U.S. is probably the biggest of the three countries. Recent investment in the technology, there again, the U.S. government has invested a lot. The military, especially in recent years, is it more than we're seeing in China? I don't know. I know China has invested a great deal in the last few years, and some of these companies are growing. The likes of BLT, Bright Laser Technologies, and other companies too are doing very, very well. And so, like I say, it really depends on what criteria you use to measure investment and growth and outcome.
So one of the things one of the challenges continues to be standards and regulations around the technology. Are we seeing some progress in that front? Imagine now, as you're part of ASTM, that you have some insight into this.
Yeah, standards are so vitally important for any industry to develop and mature. And, you can look at any industry, just look around, whether it's lighting or, material products, or, the list goes on and on. And those industries do not mature without strong standards. In additive manufacturing, the first standards committee was ASTM F42 Committee on Additive Manufacturing Technologies, which was formed in 2009. I was lucky enough to be a part of it back then, and now today we have more than 60 standards that are branded by ASTM or ISO ASTM. There's a partnership between the two organizations, and they are co-developing and co-branding not all of the standards, but some of them. And so that's encouraging. And I think that the standards are making an impact, and they will continue, as we see more developed, I think it will help the industry move to a level that we haven't seen in the past. So they really are, very important. We're seeing additive construction now, and there's a great demand for building codes and industry standards around, that industrial sector, which is really just getting started. It's hardly scratched the surface.
Well, traditionally, medical, aerospace, and automotive have been the leading cusp of development and applications, and there continues to be advancements in all of those industries. But as you mentioned, construction is starting to take off, and even some 3D printed food, which seems very odd but exciting at the same time. I think you gave an example of a cheesecake that was 3D printed. How does that work?
Yeah, so the food ingredients can be the feedstock, and so you can make chocolates, different types of candies, and where I see a good fit for that sort of thing is fairly low volume custom products where you're having an anniversary, birthday, company celebration of some sort, and you're doing logos and some kind of candy, or it could be as gifts. We're also seeing cultured meat and meats from plants where they become the feedstock, even living cells that you print. And the whole purpose of the printer in the case of meat is to give it the look and texture, so that, because if you just mix the ingredients together and lay it out, it doesn't look like a steak, for example. It doesn't have the marbling and the fat and like a steak should look. But with 3D printing, you can control that, and so you can make meat look like it's supposed to look and hopefully taste. I haven't had meat. I've had chocolates 3D printed, but I haven't had any meat. But I think in the future, that industry will sort out where there's a need and opportunity, and so we're seeing a lot of trial and error, as we are in the construction industry with additive construction. A lot of trial and error there too. They're sorting out and trying to understand, where does 3D printing offer value? Where does it have a good fit? And that's true not only with food, but with 3D printed electronics. Medicine is another area in the future that we'll see. We are seeing companies 3D print medicine today. It's relatively few products, but companies are hard at work trying to certify, get clearance from the FDA for different types of medicines.
Well, I know on the construction front, there's a BioHome, I think, at the University of Maine, had a prototype home. But I mean, that seems like a more of a specialty for lower cost housing. But where do you see the main benefit and application in the construction industry?
That's a good question. My father was a building contractor, and I grew up working for him. And then when I did my undergraduate degree in central Nebraska, I worked for a building contractor. So I have an understanding and an appreciation for the methods and materials behind construction. Am I out of date? Yes, but not a lot has changed in the last few decades when it comes to building. But to answer your question, I think the rules of additive manufacturing and 3D printing for, we'll say, electromechanical designs, whether it's for automotive, aerospace, healthcare, those rules apply also at the large scale for additive construction. And what I mean is this: if you're building a basic shape for an automobile that could be done using conventional manufacturing, and it's a very fast and inexpensive process, and that's the way you should do it, using the conventional approach. If you're doing something different, where you're trying to produce a complex shape, for example, complexity typically adds cost. And let's say you're wanting to do something to add performance. That can also add to the cost. So those kinds of, I'll call it rules, meaning that if it's a basic shape, you probably want to use conventional. If it's a complex shape and you want to do some other kind of wild things or different types of designs, then consider additive. And so I cringe when I see these homes being built with just straight walls. Now I've seen several with like really cool curved designs and different types of features and architectural elements where they're really using creative thought behind it. Okay, that's when it adds value. But it doesn't add value when you're just doing basic shapes. And I think that's where the construction industry is really trying to sort out where it adds value and where they can benefit the most from additive manufacturing.
That brings up another point, hybrid manufacturing, which combines elements of additive and traditional subtractive methodologies. Do you see that becoming more widespread where as industry kind of sorts out where additive makes sense?
I do. That's another area that really hasn't taken off as much as we thought it would when it began to show itself, a decade or longer ago. It applies most directly to directed energy deposition, where you're putting down it's almost like a welding machine with a robotic arm. They're not all like that, but many are today. And to combine that, or it could be a CNC milling machine, and to combine that with material removal, so you benefit from adding material and producing a relatively complex shape and in a fairly fast way, and using minimal material in comparison to machining a big billet of expensive material, and then most of it ends up on the floor in the form of chips. In concept, then of course to add and then remove in an optimal way to come up with your final part or product. And it's easier said than done, and part of it is the software tools that need to be developed, but it's also often on a case-by-case basis. Like you may be able to dial it in on one type of part, but then you go to another type of job, and it's so different. The source of one of the sources of the problem is heat and distortion. So these things, they get very, very hot, and as they cool, they distort. And to be able to, and that too is on a case-by-case basis. It depends on the wall thickness, the features, the part that you're producing. And so those are some of the elements that make it difficult to do a hybrid machine, is because you're, when you're going in to cut, it thinks maybe the part is, 5 millimeters from the cutting tool, but it's maybe already crashed into it because of the distortion. So, that's so anyway, I think we'll see more of that in the future, but it really hasn't developed as we thought it would, not to the extent that it has so far. DED, on the other hand, in general has. I mean, it's really taken off. We're seeing, a lot of work and investment in that area. It's very exciting, too.
Do you see any role for artificial intelligence in additive manufacturing?
Absolutely. Yeah, absolutely. The design phase, machine learning, applying AI to, the problem I just described, in fact, for it to help solve some of those problems with heat and distortion. And so, I'm certainly not an AI expert, but we are seeing examples of AI pop up in additive manufacturing, and the sky really is the limit, I think, especially when you take into account the food that we talked about, medicine, some of these emerging applications where I think AI could really play an important role.
So what other challenges and opportunities do you see in coming years, and looking forward 3 to 5 years? What's your vision for the additive manufacturing industry?
Well, first, opportunity. So I see that using, applying the technology to actual production volumes, and the volumes could be as few as a dozen or even one. If you look at the dental field, there's a lot of this technology being applied to, dental crowns and teeth straightening and models and so forth, and it's often in a volume of one. And so I think production, that's where the money is. It's not in design and prototyping; it's in production, and often custom production. For example, I have a pair of ski goggles from Smith, and the main frame was produced by HP's multi-jet fusion process, and they're custom. I use this app that I downloaded from Smith. I scan my face, and a couple weeks later, the ski goggle product showed up, and I love them. And so it's that kind of thing. But it's difficult to make a business of these new types of products because people have to pay more to get them, and are they worth it? But I still see an opportunity in that type of product, and then. I talked about the break-even point. As costs are being driven down and speeds are driven up, that break-even point will keep moving in the right direction to the point where maybe today, in some cases, it's only a few hundred products that can be produced less expensively than using conventional manufacturing. But in the future, it could be thousands, depending upon what it is you're trying to achieve. And so that's where the real opportunity lies. And, of course, the breadth of applications in manufacturing, the breadth of new materials, and companies that are beginning to invest, the likes of Nikon and others who are making a big commitment. Stryker in Cork, Ireland, making big commitments to manufacturing. They built a $400 billion additive manufacturing facility years ago, and they just expanded it recently. And so, that's a user company, and that's what drives this business is the actual customers of this. And so that's exciting. The challenges, we have many. One is we talked about design and the obstacles there. We have tools, and they're improving, and we have more talent. So as designers and engineers become familiar with design for additive manufacturing, then we have a bigger pool to hire from. And so companies do not have to grow that talent inside. They can hire somebody that already knows how to do it. So that's important. I think cost is right near the top. Cost of both the machines, but particularly the materials, because materials are still priced for low quantities. It doesn't matter if you're paying, $200, $300, $400. Well, it does matter, but not as much. A couple $100 for a kilogram, 2.2 pounds of material. If you're only using a small amount of material, but if you're using, tens or hundreds of kilograms in a short period of time, it becomes a big factor. So cost is an important factor. You talked about standards, and I think qualification and certification in aerospace, the qualification of materials and processes, and of course the certification of designs is very critical to the growth in that industry. It can take you can design and begin to manufacture parts quite quickly within weeks or even months, but it can take years to qualify and certify, and so we need to come up with maybe ways to maintain the same level of quality, but reduce the amount of time it takes to qualify these materials and processes and certify designs. So those are among the challenges. We could spend more time because it doesn't. The list does not end there, but those are some among the top ones.
Sure. So to kind of end on a positive note, I know you're going to be out at Rapid Plus TCT in Los Angeles, June 25th through the 27th. What are you looking forward to seeing out there, and what excites you about the future of additive?
Yeah, well, it's for me personally, and I think for a lot of people, it's the people that you meet, the relationships that you maintain. That connection is as important as the technology and the show, the conference sessions. They are fantastic, and I can't wait to be a part of that. But it's the people, I guess, that make this industry and in other industries fun to be a part. And so, yeah, I'm looking forward to, what's new. There's, Rapid plus TCT is a platform for new announcements. And so I'm looking forward to hearing about them and seeing some of the new machines, materials, products. Companies like to showcase their customers, the likes of the ski goggle that I mentioned and other types of examples that we get to see for the first time often at these events. And I'm lucky enough to be speaking on day 3 as a keynote speaker, and look forward to sharing some of the results of Wohlers Report 2024, as well as some of the highlights of the event. And so, I look forward to seeing you, Steve, if you're going to be there, and others from SME and Rapid News, which does the TCT branded products, and then, all of the other people from around the world that plan to attend.
Great. Well, I look forward to seeing you out there, Terry, and thanks again for joining us today and sharing your insights and a little teaser about what's in the report. It seems like there's always something new and exciting to talk about when it comes to additive manufacturing, and look forward to seeing you at Rapid Plus TCT. If listeners want to learn more about additive manufacturing and the latest Wohlers report, where should they go?
Just go to WohlersAssociates.com. You can just Google Wohlers, WOHLERS, and you'll find it quickly.
Great. And to learn more about the latest manufacturing trends and hear more podcasts, visit us at advancedmanufacturing.org.